Okay, let's walk through this problem together step by step. So we have a charged particle moving through a material called a dielectric medium. This medium has a refractive index of 1.33 and the particle is moving quite fast at a velocity of 0.8 times the speed of light in vacuum. We want to find the angle, the Cherenkov angle, at which the radiation emitted by this particle is observed. We have a few options here: 5 degrees, 10 degrees, 20 degrees or 40 degrees. Or maybe it wasn't attempted. To solve this, we need the formula for the Cherenkov angle, which we call theta c. The formula is given by the cosine of theta c equals c divided by n times v. Here c is the speed of light in vacuum, n is the refractive index of the medium, and v is the velocity of our charged particle. Now we can also write this formula in a slightly different way. If we define beta as the ratio of the particle's velocity to the speed of light, or v over c, then a sine of theta c equals velocity to the speed of light, or v over c, then the formula becomes the cosine of theta c equals 1 over n times beta. This is often a bit more convenient to work with. First, let's identify the information the problem gives us. We know the refractive index of the dielectric medium n is 1.33. We also know the velocity of the charged particle v is 0.8 times c. Next, let's calculate beta. Remember, beta is v over c. We are given that v is 0.8 c, so beta is 0.8 c divided by c, which simply gives us 0.8. Now, before we calculate the angle, it's important to check if Cherenkov radiation actually happens. It only occurs if the particle's speed is greater than the phase speed of light in the medium, which is c divided by n. So we need to check if v is greater than c over n. Let's plug in our values. Is 0.8 c greater than c over 1.33? We can cancel out the c on both sides, leaving us with is 0.8 greater than 1 over 1.33? Calculating 1 over 1.33, we get 0.7518 dot dot. So we are checking if 0.8 is greater than 0.75. Yes, 0.8 is indeed greater than 0.75. This means the condition is met and Cherenkov radiation will be observed. Now that we know radiation occurs, we can use the formula to find the angle. Let's use the formula cosine of theta c equals 1 over n times beta. We'll substitute our values for n and beta. So the cosine of theta c equals 1 divided by the product of 1.33 and 0.8. When we multiply 1.33 by 0.8, we get 1.064. So the cosine of theta is 64. Let's calculate that value. 1 divided by 1.064 gives us approximately 0.94. So the cosine of theta c is approximately 0.94. To find the angle theta c itself, we need to take the inverse cosine or arc cosine of this value. So theta c is the arc cosine of 0.9398496. Using a calculator for the arc cosine of 0.9398496, we find that theta c is approximately 19.97 degrees. Finally, we look back at our options. Our calculated angle is 19.97 degrees. The closest option to this is 20 degrees. So the final answer is 20 degrees.